projects. In this video, we are going to explain about a project titled A Deep Learning Streaming Methodology for Trajectory Classification. So now coming to the introduction part. In recent years, the proliferation of data generated from various sources has led to a surge in interest in advanced data processing techniques. One such domain is trajectory classification, which involves the categorization and analysis of sequences of spatial data points commonly encountered in applications like transportation, wildlife tracking, and mobile device localization. To address the challenges posed by the high volume and continuous nature of trajectory data, a novel approach has emerged: a deep learning streaming methodology for trajectory classification. So now coming to the objective part for this project is to offer a powerful and adaptable solution for classifying trajectory data in real-time settings. By meeting these objectives, the methodology contributes to enhancing decision-making process, optimizing resource usage, and enabling accurate and prompt analysis of continuously generated trajectory data. Another objective is to enhance the scalability of trajectory classification algorithms. Deep learning streaming methodology aims to efficiently process large-scale trajectory datasets, reducing the computational burden associated with traditional batch processing approaches. This scalability is critical for applications dealing with massive volumes of trajectory data, such as in smart city systems, transportation management, and surveillance networks. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirement. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first upload AIS trajectory dataset. This step involves obtaining and preparing a dataset of AIS trajectory data. AIS is a system used for tracking and identifying vessels' movements, and trajectory data consists of the positional information of vessels over time. Second, transform AIS trajectory to images. To process trajectory data using deep learning models designed for image analysis, you can convert the trajectory data into images. This might involve techniques like creating heat maps from the density of vessels' positions, or generating time-stamped sequences of images that capture the vessel's movement over time. Third, build VGG16 deep learning vessel classification. VGG16 is a deep convolutional neural network architecture commonly used for image classification. In this step, you would design, train, and fine-tune a VGG16 model use the transformed AIS trajectory images. Fourth, extension PSO-based VGG16 vessel classification. Here, PSO stands for particle swarm optimization, which is a meta-heuristic optimization technique. Extending the VGG16 vessel classification with PSO suggests introducing optimization into the model, possibly for hyperparameter tuning, architecture modifications, or feature selection. PSO could help enhance the performance of the VGG16 model for vessel classification. Fifth, accuracy comparison graph. After training both the standard VGG16 model and the extended PSO-based version, you would evaluate their performance using matrices like accuracy. Creating an accuracy comparison graph visually represents how the two models perform in terms of vessel classification accuracy. Sixth, comparison graph. Alongside the accuracy comparison graph, a comparison table could be created to detail various performance metrics of both models. This might include accuracy, precision, recall, F1 score, and other relevant metrics, providing a comprehensive view of how the models perform across different evaluation criteria. Seventh, start receiving streams. Once the model are trained and evaluated, you can deploy them to start receiving real-time streams of AIS trajectory data. As new AIS data becomes available, the models can process the data on the fly and classify vessels in a real time, providing instant insights into the vessels, activities, and classifications. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder named as PyCatch. In this we are containing a Python file which is containing the Python script in it. Another folder named as dataset. In this also we are containing a dataset over here in the .csv file. Another folder named as images. In this we are containing some images over here. And the folder named as model. In this we are containing some and .py files and .hy files which contain the deep learning algorithms information. These .hy files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions on new data or performing specific operations. And here these are the Python files like client, dataset, tall images, dataset to images, DP, PSO train, server, stream center, trajectory classification. So these are the Python files which are containing the Python script in it. And here this is the run.bat file. Instead of executing the program and command line interface, we created Windows bat file to execute the project. So now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. And now click on upload AIS trajectory dataset button to upload the dataset. Here I am selecting this dataset over here, and now click on open button to upload the dataset. So you can see on the screen dataset trajectory is loaded, and now click on transform AIS trajectory to images button to convert above loaded dataset into the images. So here you can see that entire trajectory is converted into image, and for sample purpose I am displaying one image which is successfully transformed from trajectory. Above image showing vessel in underway movement. Now closing this image. Now click on build VGG16 deep learning vessel classification button to train VGG16 with the above images for getting the prediction accuracy values over here. So here you can see that with VGG16 we got 93% accuracy, and we can see confusion matrix graph of VGG16 algorithm. And so now closing this graph also. Click on extension PSO based VGG16 vessel classification button to train VGG16 with PSO optimized images to get below prediction accuracy. So here you can see that PSO optimized VGG16 we got 98% accuracy. And so now closing this graph. Now click on accuracy comparison graph button for getting the graph. So here in this graph you can see that x-axis represents approaches and iterations over here, and y-axis represents accuracy or loss values over here. And in this graph, red line represents VGG16 loss, and green line represents VGG16 accuracy, and blue line represents PSO VGG16 loss, and orange line represents PSO VGG16 accuracy. And in both algorithms we can see PSO VGG16 has more accuracy and less compared to plain VGG16. And now closing this graph. So now click on comparison table button over here for getting the comparison table. So here you can see that comparison between proposed VGG16 and extension PSO optimized VGG16, and we can see extension PSO optimized got high accuracy, precision, recall, and F1 score. So now closing this window. And in this graph you can see that the algorithm names has been represented over here. So now closing this graph also. Now click on start receiving streams button to start the streaming server over here. So here we can see stream server started, and now go to code folder and we have to run stream center.bat file. So we have to run this by double clicking on this file. So here you can see that the trajectory ID has been mentioned over here. Now we have to click on stream selected trajectory button over here. So here you can see that the selected shift trajectory is showing over here. And now we can click on execution time graph button for getting the execution time graph. So here in this graph you can see that the x-axis represents technique names and their y-axis represents execution time taken by that technique. So you can try with other trajectory ID also. So now closing this graph over here. And coming back to the conclusion part, the deep learning streaming methodology for trajectory classification addresses a critical need for efficient, accurate, and timely analysis of trajectory data. By pushing the boundaries of data processing and classification, it exemplifies the power of interdisciplinary research at the intersection of deep learning, streaming data, and trajectory analysis. As technology advances and datasets continues to grow, this methodology paves the way for transformative advancements in how we understand, utilize, and respond to dynamic spatial data streams. Moreover, the deep learning streaming methodology exhibits remarkable accuracy in trajectory classification due to its capacity to capture temporal dependencies and long-range patterns within trajectory sequences. By relying on data-driven feature learning, it outperforms conventional methods that depend on handcrafted features and shallow classifiers.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.